everybody, Mr. Berry here, talking about the second part of our first unit, talking about absolute value functions. Want to real quickly go through what that parent function looks like. So we have the first occurrence of a parent function. That's really something we're going to base everything else that we do going forward off of this function right here, the absolute value. Y is equal to the absolute value of x. Of course, we know function notation would be f of x is equal to the absolute value of x. Either way, it's okay. We're going to be dealing with graphs a lot, so I would be okay with us thinking about it as a y right now, not f of x. Want to graph a thing? Remember, no matter where I plug in an x, it should come out as a positive for our y value because it's stuck there. So for instance, we start off with our vertex here. Vertex would be the point 0, 0. And we also know that the x value off of that vertex, in this case it's 0, would be our axis of symmetry. That's where our imaginary mirror would be, which we then know will have points on either side of that mirror that match up. So here, again, I'm just going to roll through a bunch of the x values and we'll go ahead and plug it in. So for instance, if we had the x value 1, absolute value of 1 would be 1. Absolute value of 2 would be 2. Absolute value of 3 would be 3. Those right there should hopefully at this point be commonplace for you. And that's going to go on and on and on forever. And I'll stop it right there. Hopefully I'll draw a straight line. Not too bad right there. We also know that the negative, so when we take a look here at the negative side of the domain, we have -1. The absolute value of -1 is also +1. The absolute value of -2 would be +2. Absolute value of -3 would be +3. Our absolute value is talking about the distance a number is away from 0. So we'll put those points in. Absolute value of -2 is +2. Absolute value of -3 is +3. Absolute value of -4 is +4. And hopefully you can kind of also see while I'm drawing this on here, the mirror right down the line here at x is equal to 0. And again, I'll try to draw a straight line for us there. Now, we know the vertex, 0, 0. We know the axis of symmetry, x is equal to 0. Let me talk about using that mirror and that axis of symmetry, kind of figure out what it is that we would have when it comes to the slope. So my axis of symmetry here, right, would be an imaginary line right up there at x is equal to 0. It's imaginary. I'm just going to write it down here. And I'm going to take a look off to the right side. And off to the right side, if I'm trying to think about what the slope would be, I'd go up one and to the right one. Up one and to the right one. And that consistently happens here on the right side. So it'd be 1 over 1 for the slope. Now obviously, we could go ahead and simplify that. And we would just say that the slope would be 1. That's going to be important as we move forward here in the class and for this unit the next 2 or 3 times we see each other. On the other side, on the left side, I always want to worry about the right side first. You'll see why in the next video. But on the left side, just to check it out, we go up 1 and to the left 1. Up 1 and to the left 1. And if I write that out, that would be 1 over -1. Simplified, that slope should be -1. All right, so if I'm looking at the slopes of both these lines, m is equal to 1, m is equal to -1, I should notice that those two slopes are opposite numbers, opposite of each other. One's positive, one's negative. Finally, the last thing I want to talk about here in this intro video is the following. We'll go back to our good old friend, domain and range, which I know some of us despise, but let's go ahead and just continue to practice it throughout. Domain and range. You're going to find here for the absolute value functions that our domain hopefully will be something that's very similar every single time. However, we want to go ahead and check it out here. Go to my arrows, check it out, see what happens. Okay, this arrow right here, this arrow is going up and to the left. This arrow over here is going up and to the right. So when it comes to our domain, our x values, we have the left covered, which is our negative infinity. We have the right covered, which is our positive infinity. Everything, every single x value on the graph is covered. We have a point at least in one location for each x value. So domain will be one of those spots, I'll abbreviate it D here, where we're going to have negative infinity is less than x is less than positive infinity. And that happens often, if not all the time here for our absolute value functions. Our range is a different story. We have to do a little bit of thinking for range because I wrote the word up twice, but I did not write the word down at all here. Sometimes it's going to happen with two ups. Sometimes it's going to happen with two downs. So our vertex here is the lowest point on the graph. It is our minimum. All right, in this case, it's a minimum, which means we have everything above that point but nothing below that. So when we take a look here and we consider that range is our y values, we know that for the vertex, our y value here is 0. Everything's going to be above it, nothing below it. So I can have y be greater than 0. That dot is colored in. That dot is colored in. So we're going to go ahead and put a line underneath it. So our range here would be y is greater than or equal to 0. We'll use this particular picture here to compare to every other thing that we do in the videos following here with a lot of practice on how to graph and eventually get the equations and functions that come from the graphs.